Back in. Everyone have a good lunch? Yes, where'd you go? Thank you. Somebody in there. So, come back for our lunch break. We're going to do the liquid waste system plan presentation. Sunny's going to give us that in just a minute. We'll take a short break afterwards, maybe about 10 minutes, stretch our legs. Then we'll come back in for ticker. We'll do public comments and then voting for the day. And then we'll be done, so we're almost there. Before we get started, are there any questions about anything we've done so far or need to do today? Nope. All right. Sunny, you ready? Let's go.
Good afternoon. Good afternoon. Okay, so there you go. Yes, my name is Sonny Blanco, and I work for Jim Folk in the waste disposition program, and specifically I'm responsible for the planning, the budget, and the coordination for the whole liquid waste program. So we can see the light at the end of the tunnel. Amen. We are so excited. We're just about there to get started with, as you know, salt waste processing facility. This is a long time coming. We have talked about it, we have dreamt about it, we have written about it, and finally we're seeing all the pieces coming together, and we just can't wait. Okay, so I was told this is counterintuitive, so let's see, forward. It worked. Okay, so I am going to be talking to you about actually liquid waste overview before I talk to you about the system plan, because it turns out to be that if we haven't talked to you completely about the liquid waste system in general, maybe the system plan was not going to be that understandable. So we're going to go through that quickly to give you a better idea of what we're talking about here. So we are going to be presenting to you the topic that we promised you, the Waste Management Committee, as far as the liquid waste system plan, but also will help you with the tank closure discussions as the one that you're going to get after this one, and also the status of liquid waste facilities that you will be getting throughout the year. You know, the list of acronyms, because that's our favorite language here. So basically, like I said, we're going to be talking about the liquid waste overview, then the system planning process, the inputs to the system plan revision 21, and the results. So let's go to the chicken or the egg. So why do we need a liquid waste program? So back in the 50s, the reactors on site were producing, irradiating targets and fuels, and then the separations operations, which is the nuclear materials program, operated for many years. They produced a total of about 160 million gallons of waste. That's the waste that we call legacy waste nowadays, and that's the waste that we're storing right now in our storage tanks. Obviously, we do not have 160 million gallons of waste right now. We only have about, let's see, we have about 35 million gallons. How did that happen? Well, the Department of Energy, and back then whatever it was called, they constructed storage tanks and realized that we just couldn't build that many tanks to store all that waste. So the waste got evaporated over the years and concentrated, and that's how we end up with about 35 million. Oh, I did the wrong thing. Okay, so let's see. Okay, so that's why we ended up with 35 million gallons. Basically, when the canyons, H canyon and F canyon, were processing the targets and the fuels, they were extracting nuclear materials that are used for different things in the medical field, the space program, and defense. And that waste got, when it was sent to the tank farms, was combined with sodium nitrate and sodium hydroxide, so it would become an alkaline waste, and because it was produced from an acid process. And when that happened, what we ended up with is a salt waste and sludge waste. Basically, the waste that was being produced by the canyons had a lot of metal oxides, like the aluminum, iron, uranium, mercury, nickel, and noble metals. And most of those are insoluble. So that's how we end up with the sludge. And as you see, the sludge is pretty thick. Some people say it looks like peanut butter. I don't know why we always compare it to food, but it's like peanut butter. The salt waste, as we concentrate by evaporation that waste, we form crystals, which is the salt cake that we have nowadays in our tanks, and salt supernatant, which is salt waste, but that is still more liquid than solid. And that salt cake still has some water in it, and that turns out to be that the majority of the long-lived radionuclides are in the sludge. That's more than 30 years of half-life. And then in the salt supernatant and the salt cake, we have the cesium daughter and the daughters and some strontium. And cesium turns out to be pretty soluble. So that's why you see that the majority of the curies in the salt are in the salt supernatant versus the salt cake. You see 12 million curies versus 120. And then the sludge has a lot of curies in it. So anyway, so that's why we're doing what we're doing. Any questions on that? And of course, we're talking about radioactivity here, radioactive waste. So quickly, we're just gonna talk a little bit about this. We got 4 types of tanks in the tank farms, and those are all underground. You've got type 1, 2s, and 4s that we call the older style tanks. And also, we have different kinds of agreements with the state to deal with those because they don't have secondary containment. But we are dealing with them, and we're just about done. The difference here is that you're gonna see type 1s and 2s. They have a 5 foot high pan. It's like a cup and saucer kind of a deal, and that's just to protect, contain any kind of leaks that we may have in those tanks. And the type 4s don't have any secondary containment at all. And the type 3s do have complete secondary containment. So it's basically a donut shape inside another tank. And all these 3 types have cooling coils in them. All our tanks are built with carbon steel. And the reason we added all the hydroxide and nitrates from the canyon is because to protect the tanks and not get them corroded. We do have extensive systems for ventilation, etc., so we can keep the tanks from corroding. Okay, let's continue here. Just wanted to give you an idea of what we're talking about when we talk about a tank. Most tanks are, like the type 3 tanks are 85 feet in diameter, 35 feet tall. The others are somewhat smaller. But I just look at the people versus the tank. The tanks on site were built at that ground level, and then they put dirt all around it and built hills, what we call hills, the east hill, the new hill. Because the tanks are, the dirt was built up around them to keep, for the shielding. And as you see, we built them across the, along, since the 50s, and the new ones, they were finished in the 80s. F-tank farm, just to give you a glimpse on when we say a tank farm, what it means. This is F-tank farm. Basically what we're talking about, we have a group of tanks in an area. You only see the tank tops for the tank farms, in the tank farm.
I have worked on every tank.
Just to give you a perspective, and when you came to the tour, and I think you came only to the DWPF. Hopefully in the next tour you'll get to see some of this. But what we're talking about here is that we got the F2 tank farms, F-tank farm and H-tank farm here. And there's a line, interior line between them, 2.2 miles long, that by pumping, we send waste from one to the other. And then the treatment facilities and disposal facilities are around H-tank farm, really. And F-tank farm right now, we are using it more for storage. H-tank farm is really where all the action happens, you know, the preparing feed, etc. for the facilities. You got SWPF over here and DWPF, Saltstone, ETP, Effluent Treatment Project. And we got one evaporator in F-tank farm, 2 evaporators in H-tank farm. The one evaporator in F-tank farm, we're not operating it anymore. We have 2 in H-tank farm that are still operating, and you have heard updates on it every now and then. We got 22 tanks in F-tank farm, 29 in H-tank farm. 24 are older style tanks. 27 are new tanks. So you might have seen this before. Just to give you an idea, we have received the waste, and we continue receiving a very small amount from the H Canyon at this point. We have 43 tanks active, 8 tanks have been already closed, operationally closed. Our salt waste will go through, right now it's ARPMCU, which that will be ending soon. SWPF coming up in the next year. And the tank closure cesium removal process, which is in demonstration at this point, and you'll get to hear about it after this talk. The highly radioactive component of the salt waste goes to the DWPF, Defense Waste Processing Facility, which is vitrified, stabilized, immobilized into canisters that are waiting to, they're being temporarily stored on site until we can send them some safe place. And then the rest of the volume, which is the grand majority of the volume, goes to Saltstone, where it's gonna be grouted and made a solid as a saltstone, and that's a permanent disposal into the Saltstone disposal units. When we remove all the waste, we proceed with tank closure as funding is available. Any questions so far? All right. One thing very important to understand is that our system is very highly integrated. There are no big spaces, storage spaces between facilities to say, okay, well, this year we'll operate this treatment and we won't operate the other treatment, and that doesn't work that way. We have the way that we have designed the system to be as efficient as possible and as economical as possible, still operating with the greatest safety levels that we can accomplish, is highly integrated. So if we want to operate DWPF, we have to be able to prepare tanks, prepare feed, so we have to remove the waste from the tanks, and and that the way it works for salt processing the same way. Until you do that, and then you can actually do tank cleaning. Tank closure is probably the only thing that we could be done separately as tanks are available for tank closure. Then you can go ahead and close them earlier or later. And NH Canyon, of course, depends on us having the space available every year so they can do their operation or their maintenance of facilities. Okay, let's see. Waste retrieval, just really quick, 35 million gallons, and we told you about 92% of it is salt. Turns out to be that when we want to remove salt waste, you saw that salt cake is a little bit solidified, and then the supernate. That salt cake, we have to combine it with more than 3, for every gallon of salt waste, we need about 3 or more gallons of water to be able to dissolve it. So from one tank, more than 3 times are produced in terms of salt solution, and sometimes we say that we're unzipping the salt cake, and it's because it's compact, and then we're making it what it was to begin with. And when we process sludge in DWPF, for every gallon of sludge that we are wanting to process through, it becomes 1.3 gallons. So in the waste that we send to DWPF and we prepare and send to DWPF comes back to the tank farms. So we are not reducing inventory in the tank farms until actually we process salt. I just wanted for you guys to be aware, and that's why you're gonna see the budgets that we have. Every tank that we have out there, we have to prepare it for feed, for waste removal, and then to be able to remove the waste for feed. And that means, we have to install equipment. We have to make other services available, electricity, water, anything and everything that is necessary to operate the equipment, so we can actually mix the waste with the water to dissolve it, and also to remove it from the tanks through, of course, underground transfer lines. And just so you have an idea, when we're preparing salt waste for a tank for salt waste removal, it takes almost 4 years, almost 3 years from the time we start preparing the tank until actually that waste is ready to be fed to SWPF or to ARPMCU, for that matter. And also for thicker. As far as sludge is concerned, it takes a lot longer. It takes about 4.5 years from the time we start preparing the tank until actually we are ready to feed the waste into DWPF. For sludge processing, as I told you, we use Defense Waste Processing Facility, and basically we introduce water again to the sludge so we can suspend the sludge. It's really difficult to remove the sludge when it's in the present form. And it gets washed, and then the resulting waste is fed to DWPF in batches. And then from there, the canisters are sent to glass waste storage buildings. And I don't know if you have heard yet, we have to multiply the amount of storage we have. We have only 2 buildings. The first building now, we're double stacking the canisters. We are doing a modification to each silo and to each space for canisters, so we can actually accommodate 2 canisters, and that has been incredibly beneficial to the program because that could be done very quickly, and now we have double the storage in that building. We have actually double stacked more than 500 canisters so far, and we won't need any additional storage until about 2029, 2030 at this point. Salt waste processing, as I told you, to get that waste removed, combine it with water, probably three or more times what the waste stored is. Then we send that to the salt processing facilities, whether it is ARPMCU, SWPF, or thicker at this point. It's a very small amount that goes to the DWPF, which is the highly radioactive portion of the waste, and then the rest of the volume goes to Saltstone to be combined. When we go, so you know, when we go through the process of processing the salt, ARPMC or salt waste processing facility, we're removing the cesium and the strontium, the highly activity components. And when we do that, we're increasing the volume by 26% of what it was originally. So when it goes to Saltstone, then it's going to be increased when it combined with the cement, ash and slag, fly ash and slag. We're increasing that volume by 76%. That's why you see so many millions of gallons of grout versus the amount of gallons that actually got processed. Okay, let's see. I'm still looking here. Interim salt processing, we're trying to remove the cesium and the strontium. We use contactors, centrifugal contactors. We actually borrowed this technology from the separations facilities and applied that technology to this process. And that's the process that we have in place right now. The actinide removal process takes care of the actinide, remove the actinides, and this resulting salt solution goes into the MCU, Modular Caustic Site Solvent Extraction Unit, and through these contactors we separate the cesium and the strontium from that salt solution. The resulting salt solution goes to Saltstone. That salt solution is decontaminated at that point. Salt waste processing facility, same technology as ARPMCU, 9 times. It should be able to process 9 times what ARPMCU does. As far as gallons is concerned, could go up to 9 million gallons. Tank closure cesium removal, that's what Jeff and Penn will be talking to you after this talk, so I'm not gonna say much about that right now. Saltstone, we already spoke about that. We received the decontaminated salt solution in that facility. It's the grand majority of the volume. It is a non-hazardous low-level waste, has a very, very small amount of radioactivity. And combine the decontaminated salt solution with cement, fly ash, and slag, and that grout formulation, that waste, then goes into Saltstone disposal units. And right now we are done with SDU6. It's already operational, and we are constructing SDU7. Actually, it was done under budget, and much earlier than scheduled. It was a big success. So tank closure. So you're gonna probably be hearing a lot about tank closure in the next several years. But just so you have an idea where we are right now, I am only mentioning here the older style tanks, so you have an idea what's going on. The ones that are still just working as storage tanks are the ones that you see up here. We have these 4 that are undergoing bulk waste removal at this point. The ones that are in the process of getting ready for closure are 4, 7, 8, 11, and 15. And we have already closed 8. So we're getting there. Okay, so any questions on liquid waste overview? I tried to brush over, but I just wanted you to have a better idea before we talk about system planning. No questions? All right, let's go. So the system plan, we We started doing this many years ago, when we realized that because of the integration of the overall system, back when we didn't have salt processing yet, we figured that we were going to fill the tanks quickly. We were doing that very quickly, and we were going to run out of space to do anything. So we started developing a strategy on how we were going to go about doing our operations and maintaining space in the tank farms. Back then we were saying we were going to waterlog and salt bound the tank farms. And good news, we haven't done that yet, but we were very close. So it takes a lot of information, a lot of plans to put a system plan together. And so we start with obviously what is it that we want to accomplish. And also we take very much into account what our agreements and discussions with our state regulating agencies have been. And of course the Environmental Protection Agency. We had many years ago, back in 2002, 2003, we agreed on several objectives, goals and values that we wanted to maintain. Obviously, so things as fundamental as we want to send as much of the radioactive components as we could or we can to DWPF, and send the least to Saltstone, and leave the least in the tanks with the residual waste that we just possibly cannot remove. So those kinds of things are what we always the basis for the system plan. And then when we are ready to write a system plan, we have the contractor and DOE agree on what those assumptions are and the inputs. So we get the results that we're looking for as far as trying to meet the goals that we may have at that point for the system plan. Then as far as the system plan itself, we need lots of things to be prepared so we can have a doable system plan and operational strategy. And SRR, in this case, the contractor, prepares batch plans for sludge, for salt, what's the plan for the evaporators. All those things are used when the system plan is written. So at that point, the contractor produces the liquid waste system plan, and basically is the strategy on how we are going to go from now until the end of the life cycle. What are the major activities that need to be done to accomplish whatever goals we have established for the system at that point. And you are going to be able to find the document in the website for the Citizens Advisory Board. So basically at this point, our system plan, we're producing another one because the last one that was written was back in 2016. And at that point, well, the situation was pretty different. And the funding outlook, we thought that we were going to have a liquid waste contract already established after we had revision 20. There were many things, the circumstances were quite different, and we thought that the next liquid waste system plan would be issued after the new contract was in place, and the new contractor would develop their baseline and a new system plan with the strategy that would include what their winning plan was at that point. But that has not happened, so we figured that we definitely needed to move forward with the system plan so we could actually make progress, because you know, it's one of those things, you get on a train, you gotta know where you're going. If not, who knows where you're gonna end. So we definitely need to have another system plan, and then we said we'll just adjust when the new contractor is in place, and we'll figure out at that point if there's anything that needs to change, hopefully for the better. But otherwise, we are going to continue the course with what we know what to do, with the best ideas we could come up with, and have the system plan put together. So what are the things that are different? that from revision 20. First of all, we increased the utilization of the thickers, the tank closure system removal. In revision 20, we said we were going to demonstrate it, but we didn't include it as part of the plan to process salt. Apologize. Also, startup of SWPF. Back then we were saying that we were going to do, oh my gosh, I did it again. Okay. Back then we were saying it was December of 2018. That startup date, as you all know, have changed a little bit. And by the way, you see slide 32, slide 30, 31, 29. You need to correct your slide in your package, please. Acceleration opportunities. We're also starting up SWPF, and instead of having a step change ramp up of the facility, we are going guns a-blazing. So that's why that's important. Funding adjustments. We just see things being much better for us in terms of funding outlook. Regulatory agreements. At that point, the dispute resolution agreement was still in draft, was in discussion. Now we have this dispute resolution agreement in place, so definitely we are including that as part of the way this strategy was written. And several things happened in our infrastructure. With the 3H evaporator failed and required repair, melter to reach the end of life, and, excuse me, some other things in the document safety analysis area needed to be changed based on information that we learned. So that's not necessarily visible in the strategy, but the way we handle things is changes. So we had to take that into account. Our system plan, that strategy includes chemistry. It doesn't have black boxes, so the chemistry is taken into account, material balance, all those things. So it's not really a cartoon. There's a lot that goes into it. Okay. Key inputs, the priorities that we reestablished, because the priorities for system plan Rev 20 were a little bit different. Funding profile, the SWPF, startup and processing, thicker assumptions, canyon processing plan, all that is needed as an input. Priorities for revision 21. Well, now we're talking, how are we going to actually complete this mission? So the system plan Rev 21, we say what's the best way we can actually complete this mission and do it the fastest possible. So that's what, besides obviously safe storage of continue with the safe storage of the waste, we're saying, okay, so how do we complete the system operational closure now? And we said, let's try to get F-Tank Farm out of the way first. And then, of course, we have to have the agreement, respect that in terms of processing rates, etc., which is very helpful because helps react with acceleration. And then we wanted to make sure that we would take care of those tanks because they are very close to the water table or in the water table. We wanted to take care of those as soon as possible. And with the intent of closing F-Tank Farm as soon as possible, we wanted to see, let's put some effort into getting the services in the tank farm taken care of and closed. Funding, at this point, what we said, all right, we knew FY19 budget. From then on, we told the contractor, just tell me what it takes to get this thing done. The sooner, the cheaper it's gonna get. So let's just find out exactly what needs to get done. SWPF, just for planning purposes. It doesn't mean that SWPF is gonna start in March. This is just for planning purposes. We just wanted to introduce a little bit of conservatism. So we would say the day after it got signed is no good anymore. So we just added a little bit of conservatism to the plan. And we said hot commissioning starts in March. The first year of operation starts in May. And the first 12 months of SWPF, we're going to feed them 6 million gallons. They're going to process 6 million gallons. And we are assuming that the next generation solvent will become operational in SWPF sometime before the beginning of the second year of operations. And then at that point, they're going to start processing 9 million gallons. This is really important because it means that we have to be able to feed them that much. That's a lot of work for the rest of the system. And we're also assuming that ARPMC will operate until 5 months prior to the SWPF hot commissioning date. Assumptions between Ref 20 and 21. I just wanted to, so you have an idea what I'm talking about. I told you that SWPF was going to be, was increasing as a step change. In Ref 21, you see 4.6, 7.2, 7.2. So it was more of a gradual increase. Here we are like, okay, we're giving you a year of practice. After that, you're off to go. So that's basically what we're talking about here as far as the processing rates for SWPF. Thicker assumptions. So now we are assuming success with the demonstration, which is looking very good. So we feel good about this one, and we are going to be introducing. We introduced in the strategy 2 units of tank closure cesium removal. So the assumptions are a little bit interesting. For the first thicker unit, we're going to finish the demonstration in tank 10. And then we are going to be leaving it where it is right now and go ahead and process waste from tank 9. So that way we don't have to relocate it, and we can start using it fairly quickly. And then after processing the waste from tank 9, we're going to relocate it to tank 21 in FY23, and we'll continue processing dissolved salt until it's done. And that's just about 2029. At least that's what the strategy says at this point. For the second thicker, we're saying, okay, we're going to buy a second unit. We're going to go ahead and deploy it in F-Tank Farm, start processing in fiscal year 22. For both thickers, we're assuming 1 million gallons a year. And then after, in about FY26, we're going to relocate that unit to also by tank 21 in H-Tank Farm. Remember, H-Tank Farm is where all the action is, and the plan is to, after we do what we can in F-Tank Farm, get F-Tank Farm closed, and then we can reuse that second unit in H-Tank Farm. And they both finish about 2029. Okay. Evaporators and DWPF recycle. I told you about the evaporators at the beginning of the presentation, and they continue to be a very important component in our system because when we process in DWPF, I told you about the sludge producing more liquid than what we're sending them. So they send about 2 million gallons of liquid back to the tank farms every year. So we said, oh my gosh, so we need to continue evaporating the waste, and we use the 2H evaporator for that. The idea is, let's talk about the DWPF recycle first. SRR is proposing to divert the recycle by 2023. They're evaluating alternatives, and looks pretty good about sending that waste to the effluent treatment facility after some treatment and not have to introduce it into the tank farm anymore. So that really lowers the use for an evaporator. And then the 2H evaporator takes care of that recycle. The 3H evaporator takes care of washing the sludge, the water that comes back from washing the sludge to be fed to DWPF. So between those, getting the recycle diverted, then the 2H evaporator could start working on the sludge batching, sludge preparation, and then the 3H can then be retired. And the 3H evaporator, the strategy says that we're going to shut down in 2026. Then the 2H evaporator is going to be later. It's going to be 2030. Other inputs, H Canyon continues. Sending us, they send us a very small amount. We planned for 300,000 gallons, but they never make that much. We are saying we can accept until FY30. Tank 48, this is an oddball. We have some waste in there that we need to take care of, and we are going to hopefully start working on it very soon in the next couple of years and take care of it, and actually have it closing, in the early 30s. DWPF, we continue to synchronize the canister production with salt processing. Results. Okay, so we're very excited about this. We're saying, okay, so if we go the way we say that we can do, we will empty F-Tank Farm. We'll remove all the waste and send it for processing by December of 2030. And we can actually cut the interior line. That's all, that helps also in regulatory space. So basically we would be, F-Tank Farm would become a tank closure kind of a site where we would be doing grouting services at that point. SWPF would complete operations by December of 2030. F-Tank Farm, we can close it by middle of 2033. Then the removal of all the waste from H-Tank Farm would be completed in 2034, and that's also when DWPF ends. When you look at all our tanks that are left to be closed, dealt with and closed, I can see that by 2035 we have taken care of the grand majority of the tanks. 44 out of the 51 are closed, and then we have about 7 tanks to take care of as far as tank closure is concerned, and they will be done by 2037. But basically, all operations in liquid waste will be done by 2034. So definitely that beats 2041, which that's what the revision 20 was saying. And these are just dates to compare with revision 20, but basically we're talking a few years of acceleration. When you look at the actually processing waste, we're talking about, let's see, complete salt treatment is on, a year difference. Actually, DWPF, the sludge treatment, this is supposed to be 2034. I apologize for that. But basically, actually getting everything ready and turned over to D&D is quite a bit earlier, 4 years earlier. SDUs, we're talking about 14 SDUs in revision 20, we're talking about 13, but that SDU 13 is probably going to be very, very small, probably like 3 million gallons or so. I just wanted to show you how bulk waste removal looks like. We are going to be, let's see, well, obviously we're going to continue to empty tanks as we go along. But as you see now, we're talking about the compliant tanks. So we're going to get into that very quickly. In the next couple, 3 years, you're going to start seeing we're going to be going into the compliant tanks or the new tanks. And we're going to be done with the older style tanks. This 4 is on purpose because they're very good tanks, don't have cooling coils, and we use them for processing, help us with the processing of the waste. This is tank closure. So we're gonna be closing as early as FY24, 1 tank, but as you see after that, hopefully funding will show to support us in this endeavor, but after that you're gonna see that we will have multiple tanks per year being closed. There are just a couple of years that we may see 1 tank only, but after that we're gonna see multiple tanks every year. So we're serious, and I think that congressional staffers are seeing that this is really happening, and we're getting excited. We're getting the support that, at least for now, we see support that to actually make this happen. All right, so that's what I have in slides for you. Any questions?
All right, who's going to be first? Jim.
Thank you for the presentation. One of the things that has been discussed a little bit is operating H-Canyon at full capacity to reduce the inventory of aluminum-clad fuel rods. Does that impact the ability of the salt waste processing activity to continue to stay on schedule and process that volume, or does the additional volume from the H-Canyon pose an issue?
At this point, it doesn't pose an issue yet. We're going to continue with our strategy. H-Canyon, the Nuclear Materials Program, they are looking at their mission and then see how they can best use the capability that we have at this point. And beyond the years, beyond the schedule that we have laid out here, they're looking at what is that they could do to use our facilities as the way we have it set up, or what's going to be the alternative. So at this point, there are no changes to what I'm showing you.
Okay, thank you.
You're welcome.
Doug.
Doug Howard Cap. Sonny, thank you very much for your presentation. Your presentations for me have gotten easier and easier for me to understand, so I certainly appreciate it. Can you go to slide 22?
Is that slide 22? No. There you go. Uh-huh. Is that it?
Yes, 22. Okay. You have only tank 41 can be treated solely with DTA. Did you explain that, or what is that all about?
Yes, that's back in before we had ARP-MCU online, actually before it got designed and constructed. As I told you, we were at a point where we were really running out of space in the tank farms. And we figured out, as we were working our way into getting a salt processing technology established and a facility that could actually process the waste in production capacity, we had that discussion with the state, and we told them that we had an idea, which was to so we could open space in the tank farm so we could actually start salt processing, because to be able to do process salt through a facility, we needed to be able to prepare the batch, and there was actually no space significant space available in one tank where we could actually prepare batches for that. for that process. So, you know, an ARP-MCU started up in 2008, but we needed time to do things. So we started discussing this idea of, it's escaping me the three words, the liquid, oh my gosh, wait a minute, hold on. I can tell you right now what it is.
Sunny, deliquification, right?
Deliquification, dissolution, and
adjustment.
adjustment. Yes, I'm sorry about that. Basically what we were doing, remember I told you about the cesium and strontium being the cesium very soluble in liquid, in water. So we realized that the cesium resides in the liquid, in the supernatant. And the salt cake was pretty clean, you know. So we discussed with the state and said, what about if we remove that liquid from the salt cake and dissolve the salt? We will sample, we'll definitely sample and report to you what is the radioactive radionuclides level in the salt cake after dissolution, after removing that liquid that contains the cesium, and that salt dissolved that has been basically decontaminated, send it to Saltstone. And that way we are able to open a white spot in the line where we could start preparing batches for the salt processing facility that we wanted. You know, we were thinking about ARP-MCU, so open the space so we can actually process salt. And they accepted and actually became very successful. The theory was, you know, our theory was true, and that salt cake was dissolved after removing the liquid. It was adjusted chemically, and then it was sent to Saltstone. At that point, we were able to process, I believe it was about 2.8 million gallons through DDA, and we were able to lower the level of waste in tank 41 tremendously. And that way we were able to get started, and by the time ARP-MCU were constructed, we had a way of preparing batches for salt processing. And that was a very limited and monitored process by the state. And from the beginning until the end, until we declared we were not going to use it anymore because it was really not necessary. And with that, we proceeded with the ARP-MCU.
Thank you.
Okay.
You're welcome.
Malcolm?
If you could refer, excuse me, if you could refer to slide 31.
Sure.
I'm
Yes.
trying to understand more fully, and perhaps you've explained it, but I just didn't catch it readily. The assumptions dealing with the throughput of 9 million gallons a year after the first year. In other words, in your revision 20, you had a ramp up to 9 million gallons a year. We all know that if you're going from a kind of a prototype to something that makes any sense, it's a long-range process, and it's not easily reproduced.
So, and that is, you know, that's an excellent comment, and we have been operating in ARP-MCU for many years now, since 2008. So there has been a lot of exchange between the design, the construction, and the operation readiness for operations of SWPF with the pilot facility. And from the technology standpoint, we feel very confident that the SWPF is going to work in that sense. I don't know if you have anything else to add, Jim?
Yeah, one thing on that one specifically, again, Jim Folk, DOE. that Sonny had referenced earlier that we also incorporate the regulatory activities that go on in that process. So what you'll remember is that in Rev 20, and you'll see it there kind of in script, it decoded a little bit, but NGS was going to be implemented in year 4. One of the agreements, or part of the agreement we came out with when we discussed the dispute resolution, was to incorporate NGS, that's next generation solvent, into SWPF by the 2nd year. And that's really what you see there. That to get to that 9 million gallons is NGS fully implemented.
Exactly.
And so by doing that in Rev 21 by that 2nd year, that helps get that jump up that much faster.
Yeah, I just, that's aspirational goals, and it'll be good if y'all meet it, but almost every ramp up that you've gone from in the DOE complex, going from a prototype up to the real deal is not a one-year gig. You know, it's a difficult process. DUF6 is a great example, but there's any number of processes like that. So this may be an interesting area to look at more fully.
Well, yeah, and I'd also offer up there, you know, two pieces of that, I guess, is that, number one, yesterday you heard the term art of the possible, right? So the challenge as part of this Rev 21 is, what can we do?
Yes.
And the point here is, in 10 years, we can get out of F-tank farm. If everything comes in, sunny side up, admit it. And in nominally 15 years, I'm still getting Sunny to close those up a couple tanks a little bit earlier, but in nominally 15 years, we can be done. So what Rev 21 reflects is the art of the possible for the liquid waste program.
Okay.
And it was also a guide we used when we had the recent suspension agreement discussions with DHEC and EPA here a couple months ago. So, you know, that's a key part of it. The other part, you're right about implementation and issues that happen with implementation, but important to recognize is that our SWPF friends have already completed the modification to SWPF that will allow NGS implementation. So we were able to do that from some of their efficiency in construction and some cost savings they've had. I think that was about a $20 million facility that we've actually added to SWPF, which will help us implement NGS.
I just make the comment because we all know that once you put something down on paper, for whatever reason, that starts taking on the life of its own, and people start having those expectations kicked into it, and those are aggressive expectations going from demonstration technology to full board technology in a one-year kick.
This would be a good life to have.
Yes, okay.
Any other questions, folks? No? Okay. Thank you, Sonny. So, folks, I'm looking around the table and I'm seeing a little bit of a post-lunch lull. Let's take 10 minutes, come back at 2:22, and stretch, get something to drink, come back to the table, and let's power through the rest of the afternoon. Hey, let's grab our seats. And I think we have enough in the room that we can get started. Last presentation of the day, and then we're going to do public comments and then do some voting this afternoon. So with that, I want to give you Jeff Bentley and Penn Mason.
Good afternoon, everyone. I think I'll start with some introductions. As he said, I'm Jeff Bentley. I'm with the DOE, where I work in the Waste Disposition Programs Division. I'm a program manager. One such program that I happen to manage is the treatment process called tank closure cesium removal, or TCCR. Here with me today is Penn Mason. He's a senior project manager with Savannah River Remediation. He happens to be one of the people who did all the hard work in making TCCR come to fruition. When I asked Penn here to do this with me, he made a comment that it's been quite some time since we've been here in front of the cab to give you an update on TCCR. In fact, I believe it was October of 2017.
Correct.
Right? So the decision was made that we're going to kind of go back from the beginning, give you a little overview, and just give you the reason why that the TCCR project was pursued, some of the requirements that we had for the system, what we wanted to achieve with the demonstration, and then the results thus far. All right. So why did we pursue it? I think it was mentioned earlier today, a few years back, that the department and the state of South Carolina, they put some litigation aside and came up with an agreement. The agreement called the Dispute Resolution Agreement, signed in October 2016. It just so happened that agreement stated that it would add additional treatment processes to supplement the already planned processing rates that we had. In addition, it specifically called out that the treatment process that we would implement next is an ion exchange technology. So that's why we pursued TCCR. Why did we pursue it on Tank 10? Well, around the same time we had a federal facilities agreement milestone for a bulk waste removal complete that was due in 2018. And Tank 10 was a very good ideal candidate. The material inside was an ideal candidate to run through the TCCR process, so we decided, hey, we'll implement the process on Tank 10, satisfy the dispute agreement, and then satisfy the FFA milestone. Since that time, just recently, I heard in the last presentation about the suspension agreement. Well, that was done earlier this year. From that suspension agreement, we also now have a commitment that we would extend the TCCR process to treat Tank 9. All right. The TCCR process has several key benefits. One, as I just stated, it supplements our salt processing, and it allows us to accelerate closure of our non-compliant tanks. It provides a risk reduction in times of salt waste processing facility outages, because the TCCR process is not dependent on any of our other facilities to be operational. It's only dependent on some lag storage space that we have in our Tank 11. It demonstrates an at-tank treatment technology, which has always been something that the department has strived to do. It's modular in nature, and that modularity allows it to adapt to varying feed streams. Sonny mentioned that by 2023, I think it is, we want to find an alternative process to deal with the DWPF recycle, and it is possible that the TCCR process could do that. If feasible, we do plan on building the second TCCR unit in that tank farm. And then I just wanted to mention that it's also applicable to some of our other sites within the complex, and it just so happens that Hanford has has started pursuing a project, they call it tank side cesium removal, that mimics this one here, to start treating their waste to prepare it for their feed for their low activity waste vitrification. Sunny hit this slide in her presentation pretty hard, so I just want to point out a couple things. So TCCR over here, as I said, it's not dependent at all on any of these other facilities to run. Okay, you can notice that you don't see any lines going to SWPF or over to DWPF. The only one you do see is Saltstone. That's because ultimately the material that comes out of TCCR will ultimately end up in Saltstone. All right. Conceptually, this is how it works. We have a bunch of salt in tank 10. We add water to that tank to dissolve the salt. Recirculate that water until we get to a point that we feel it's got the right characteristics to send through TCCR. We'll deploy a small sample vial of our resin that we use into the tank to perform an equilibrium test. Once those test results come back and they're deemed good, we'll send the material to the TCCR. Inside there, it goes through a pre-filter, and that pre-filter is designed to take out any solids that we happen to carry over and send to it. The filtered material then goes through the ion exchange columns, and what we've been doing is running 2 columns in series. We call it a lead column and a lag column. It essentially just goes into it's a big steel column that's filled with a small bead. It's a resin, and as the material goes down through that resin slowly, the resin itself has a strong affinity for the cesium that's in the waste, and the cesium then absorbs to that resin. And so out the back end of TCCR, you've got a decontaminated salt solution stream that that's had most of the cesium removed. From there, that effluent's going to drop into tank 11, and that's where I said before, that's our only choke point right now, is how much storage do we have there that's available. We'll take a sample in tank 11 just to confirm that things are as we expect them to be, that they meet the waste acceptance criteria that we have for our Saltstone facility downstream, and if so, it moves on to tank 50 and then eventually on to Saltstone. If you're asking what happens to the columns that are in the tank closure cesium removal process unit, as they fill up, basically all the sites are taken by the cesium, and at the end of our demonstration period here, we'll actually take those columns out, move them over to what we call the Interim safe storage facility, where they're going to sit until either A, we dispose of them, the material through Defense Waste Processing Facility, which is our current path, or we find an off-site repository that can happen to accept that can take this waste from us, then we'll pursue that path as an opportunity. Don't know how many of you are familiar with H Tank Farm now. I know there's a lot of new faces on the cab, but this is a location of where tank closure cesium removal is. There's 4 tanks down here. There are tanks 9, 10, 11, and 12. And these are the first 4 tanks that were built in H Tank Farm. They're type 1 tanks. Sonny mentioned the different types. So they're non-compliant tanks. They do not have full secondary containment. They were built to support, so it was in the 1950s, to support operations at H Canyon. Unfortunately, back in that time, we didn't really have the pumping technology available in order to send the material from H Canyon all the way over to these tanks. So we had to be a little clever in designing. We had to utilize gravity to make sure that we could send the material from the canyon over. So these 4 tanks are built actually down below grade, okay, and happen to be in the water table. So that's another reason why these tanks here are very good candidates for the tank closure cesium removal. It's because we want to get the material out of them as quick as we can, and and close that risk that we have with those tanks. Some pictures for you to let you know what it actually looks like. Some of the CAB members, I know the older ones were out there last year and had a tour of it. On the right-hand side, this is the process unit. I just want to point out, there's a door here. This is an airlock on the right-hand side. There is a wall separating this airlock from the rest of the unit. It's shielded quite heavily, so that a person could actually enter this airlock while we're processing. It has a lot of our programmable logic controllers, so if there was an issue with one of those, they could go in there to fix it. All the columns, all the piping, the filters, and everything else is on this side of that shielded wall. Over here, this is our ventilation skid. I just want to point out that this ventilation skid does not provide any process vessel ventilation at all. It is simply there in case we ever had a spill inside of our processing unit. It's there for contamination control in that event. Some pictures of what our tank tops look like, and just to give you an idea of how congested it is on our tank tops. We use flexible hose and hose transfer piping to move the material from the tank top to the TCCR unit. And so this is to show you, we can't simply lay this stuff down on the ground. It would be winding around things up and over. So we build these elevated trays that then provide a clear straight shot from the tank to the TCCR unit. And then they also help support those transfer lines. If you went out there today, it doesn't look exactly like this. You wouldn't be able to see, you look over here on this picture, the two lines on the right, because this is the line that comes from tank 10 and feeds the TCCR. This middle one is our recycle line, so it sends material back. For example, when we clean our filters, backflush our filters, that material needs to get sent back to tank 10. And because that material is quite hot, it has these two lines have shielding in the form of lead blankets over them, so you can't actually see it. A lot of people ask me what the interim safe storage facility is like, and there's really not much to it. It's a concrete pad with these steel supports that are embedded. Steel supports called stanchions. You'll notice that on these supports, you basically got what looks like a flange on it. And that's because it mimics our processing unit. Inside, when we take our ion exchange columns out, we actually leave them in their shield container as well, so that we don't have to we'll provide shielding when we take out and people don't receive a dose. But on the side of those shield assemblies are beams, and those beams kind of acts like, the best way to describe it is like a rail system. They basically slide right over these flanges, and they keep the whole shield assembly with the column in place and stable. As far as our demonstration project goes, we had a few things we wanted to accomplish with it. We expected that the salt in tank 10 would make approximately 600 to 750,000 gallons of salt solution with a curie content of approximately 16 curies per gallon. We were going to load each column with approximately 25,000 curies each, and the idea was to show that we could achieve a decontamination factor of over 1,000. In addition to that, obviously during this demonstration, we're going to gather as much data as we can, and we wanted to see just how well those pre-filters were working. We want to be able to change our processing rates throughout the demonstration, kind of try and along with like doing our equilibrium test, we wanted to come up with this optimum feed control strategy. And then we also wanted to measure real rad rates, right? So we could figure out just how effective the TCCR unit is. At the end of all this, we're to deliver a feasibility study. This is this is a milestone out of that dispute resolution agreement I mentioned earlier, which we're on target to fulfill by the end of September. I think you can probably read this on your paper slides, maybe not so much up here, but this is our actual project timeline. So this project started in basically, I think it was July 2016 that they let the contract to the subcontractor to design and fabricate the TCCR unit, and it was basically 2 years from that point or a little over 2 years from that point until we had that FFA milestone. So I just wanted to point out a couple things. Right here, this bar, this is our factory acceptance testing. You look at that bar is 6 months long. Just wanted to state, you would never expect it to be that long. Actually, at the most, probably maybe 2 months to go ahead and test this out. However, I just wanted to point out, because during our factory acceptance testing, we had an issue. I think the subcontractor was really focused too much on our ion exchange columns and kind of overlooked the pre-filters. And they designed the system to be a one-time pass-through. So in the field, this is fine. But in factory acceptance testing, you don't have that luxury. You don't have an unlimited supply of water or cement or where you want to send through, and then dispose of it. So they actually have to recycle that material back. In doing so, they did not, what I believe is they did not flush the columns enough to remove all the small little fines that are in there. And so when they started up our testing, material went through, it picked up a lot of those fines, went into the recycle tank, got sent back into the front end, and basically blinded our filters, completely plugged them. And it took us 4 months to recover those filters back to the original state. Another line I wanted to point out, key one here is that's our safety basis development. It did start early on in the process, which is what you want it to do. However, you can see it lasts quite a long time. In fact, it lasts longer than the design, than the fabrication, and the installation of the unit. We were still finishing our safety basis, after everything was installed. That's really a factor of competing. It's a priority factor issue. We were competing for resources with some other projects that at the time happened to be higher priority. You could probably guess which one that was. Starts up later this year. But when we finally did get the resources, we were able to finish it up. One positive thing is nothing, while we did have discovery and safety basis in the safety basis or area after installation, nothing that we found were major impacts, okay, that would make us go back and have to totally redesign the system and spend millions and millions of dollars. So that was a positive. And one last thing, let's see, I'll show you, is where we're at today. So here in fiscal year 2019, you can see by this line that we've actually started the demonstration. We started that demonstration back, it was January 16th of this year. And to talk a little bit more about that demonstration and what we've found out thus far, I'm going to turn this over to Penn.
Okay. Everybody can hear me? All right, good. Okay, that works. All right, so thanks, Jeff. So Jeff and I obviously been tag teaming this. Jeff did a great job presenting the front end of this. I'm going to tell you where we are today. I've left this slide up here. It's a good transition slide as we get into start talking about operations. As Jeff pointed out, we're here in the backside right now as we have started into our processing. Right into this period of time through here was a very critical time and a lot of work went on. And so I want to review that time with you before we actually get into the processing. So we're going to talk about the last 6 months or so first. Did I do this right? Nope, go the other way. Okie dokie. All right, so completing the installation and moving into readiness. The document and safety analysis. Jeff talked about how complex it was, and it was very complex. This was the first documented safety analysis turned in the complex that involved ion exchange on salt waste. We're using a very unique resin called crystalline silicotitanate. I won't say that again from now on. It is CST, and CST is the ion exchange resin. That's the magic that makes the black box work. All right, so the CST and ion exchange in this safety basis, it took quite a bit of engineering analysis. It took 15 specific admin controls to put in place. Most of those were involved around the chemistry within the tank. We did include a backfit analysis for a water jacket around the column. Okay, what does that mean? We have a column. You've seen the column. It was in one of the earlier slides. It has lead shielding around it. It is unique to each of the columns, and there's an annular space between the column and the shield, a couple inches, less than a couple inches. We made the decision to fill that with water, and by doing that, we were able to convect heat quicker outside of the column. The CST process, the resin, the ion exchange process creates heat. We need to get the heat out of the column. And so by doing that, we were able to conduct heat quicker outside of the column. So we did backfit the water jacket into the ion exchange process, further complicating the DSA. I do want to point out the DSA submittal, when it was introduced, DOE was working very closely with us, both our project group and engineering group, and most all of the questions and comments for submittal, and that DSA flew right through with a quick approval. And every time I get a chance to congratulate and thank our DOE partners, I want to do that. And so again, it was very quick and all went well. On to the on-site testing. Just a reminder that this was the DOE, or the ticker equipment was built by Westinghouse Electric. It was done near the Hanford site in Richland, Washington. It was designed to be modular. It was designed to be assembled and disassembled. And so once it went through factory acceptance testing and was approved for shipment, we then broke it into 9 different trailers who trucked across the country and then was reset up here at Savannah River. And in doing that, you're darn right, we're going to test it again. All right, so we've got to put this erector set back together again. And it came with operating instructions, just like the Lego blocks, maybe a little bit more complicated. And it is nuclear safety, right? So you got to put them all back together again, right? You got instructions on how to do it. All the parts fit together, and then you got to go test it. So we tested. So, well, the first thing we did, got it right, is we were able to blank off the lines going to tank 11 and to tank 10. And we created basically a tank with a recycle system similar to what Westinghouse did, but we put some more filters on it. We weren't going to do the same thing they did and clog up the filters just like Jeff told us. So we made sure we had a good system. We made sure we had additional filters on the recycle loop, not on the process loop, but on the recycle loop. We were not going to send any fines back through the system and have the same trouble Westinghouse did. So we did that. We isolated the system. We created a test loop, and then we started testing everything. Everything is computerized, so we had all the communications to every instrument. We had all of the leak checks, every pipe, every joint, everything that we could look at, we looked at all over again. And we made sure that system was operating exactly as it was supposed to. The other thing we did that was key to all of this is as we were doing this, we went and actually got the operators that were going to be running ticker. So we pulled them aside. They learned ticker. They worked with the startup engineers. We actually had our operating procedures drafted. We mimicked our operating procedures with our test procedures. So the actual people that were running the system were running it during testing. Okay, so all of this was going on while the operating procedures were being finalized, while the training procedures this was a part of their training. So each one of the operators that was trained went through a ticker training, went through ticker DSA training, went through, after the DSA was approved, we had to go through a Delta training, and then each one of those operators went through what we call practical factors training, and each one of those operators then had to take a written test and became certified as a ticker operator. So yes, we have certified ticker operators running this equipment. We talked about operations and procedures. We were able to also break out the salt dissolution piece. We wanted to get water in the tank. We wanted to get that salt dissolution activities working as quickly as we could. So we were able to break out the salt dissolution piece. Salt dissolution is something we do every day. That's not new. We don't need to run that through a readiness assessment or anything like that. So we broke it through, we utilized a management checklist, and we started early salt dissolution. And then finally on the ticker equipment, we had a facility assessment, facility self-assessment or safety assessment, a readiness assessment, and then DOE had a shadowed DOE assessment in which we were able to get through, and we also used the same test apparatus all set up with water, so we're able to actually run and operate all of the ticker equipment using water and the procedures during the facility safety assessment and the RA. Oh, and also the drills during the FSA and RA, we were able to use that water run equipment that was in place. All right. So, then we finished up, then we got approval to proceed, and as we began to proceed, this was our baseline plan for operations. You'll see 6 campaigns. Each one of those campaigns was 100,000 gallons plus, making up the 750,000 gallons that Jeff spoke about. Each of those having a time period, you can see the time period between them, about 55 days each, which I'll go over in just a second. Starting in December 2018, finishing in November. So we're slightly ahead of the November 30th finish date. And so this was our plan, this was our baseline plan to get started. Now each one of these campaigns is broken down this way. The first 10 days is water additions, and then recirculation in the tank to enhance the salt dissolution. The next period was the CST, again, crystal and silicotitanate resin that we use in the tank. The qualification included taking a very small amount of that, put it in what we call a tea bag, and which is a stainless steel vial with windows cut in each side and a mesh in the middle of it with a very, very small piece of CST in it. And what do you do with it? You put the CST in the tea bag, you drop it in the tank. Excuse me, you never use the word drop in a nuclear facility. You lower it in the tank. I've been told that a number of times. So you lower it into the tank. You let it sit in the tank for 10 days. It reaches equilibrium in the tank. And then after that 10 days, you withdraw, remove, you don't yank or pull, right? You withdraw, you remove it from the tank. You take the CST coupon up to SRNL, and you get to this 21-day analysis period. What does SRNL do with it? They analysis it for cesium and all the other constituents to match the DSA. And at the end of that period, there's a go, no go. If you're within the constraints of the DSA, you're good to go. You start processing. If you're not, you got to repeat this process. And then you process for 14 days. So each one of these campaigns is about 55 days long. That was the plan moving in. So what happened on the first campaign? We said, as I said earlier, we took an early start on the campaign by breaking out the salt dissolution and started it early, which was on 11/8. We added 150,000 gallons of water. We circulated for 10 days. We measured density readings, and we deployed the CST samples, the tea bags, into the tank. And we came back and said, okay, what do we have after 10 days? Well, the analysis indicated that we had very low sodium concentration. And low sodium concentration means your sodium's too low. Your sodium needs to be at a certain level. 3.2 molar is the minimum to satisfy the DSA. That is how we control loading onto the cesium loading onto the CST. You control it by regulating or making sure you have enough sodium in place. Sodium and cesium compete for the solubility sites on the CST. So that is how we know how much CST we're putting into the tanks. So we had low sodium. What does that mean? It means we have to remediate that batch. So that was the first thing we learned. We have to increase the sodium. The next thing we learned is you think, okay, why do you have such a low amount of sodium? And what we found is a very, very low solubility salt layer. We call it Burkite. Don't know the chemical formula, but it's high in nitrate and nitrite. I call it hard salt. It's just hard salt. It's hard to dissolve. You can dissolve it. We have some experience with it in other tanks, but it's hard to dissolve. We also learned that batch had a high calcium content. Calcium also competes with cesium and sodium for those solubility sites onto the CST. So, first batch, 150,000 gallons. I've stirred it up. I'm ready to go. And I find out that it's got to be remediated. So we added 5 tankers of sodium hydroxide. So we're trying to get the sodium level up so we can process that batch through ticker. Again, the magic number, 3.2 molar sodium. Operation started January 16th. We completed February 15th. We have an indicated decontamination factor of about 5,000. Where did we get that? We have rad elements, rad detectors on our transfer lines going into the enclosure, the ticker enclosure, and coming out of the ticker enclosure. You measure the variance between those rad detectors, and you come up with about 5,000 for the first batch. Our takeaways here, the ticker equipment did great. We didn't feed it with really good stuff, but what we did feed it with, it operated really, really good. Okay, no operational stoppages. We did confirm the presence of Burkite, and we did learn that calcium, again, competes with those solubility sites, and so we need to get rid of the high calcium. So we put a modification in place to use domestic water versus well water leading into the next batch. Domestic water is lower in calcium. Okay. So here's all of this is what I just said basically in pictorial form. You can see here batch 1, here starts batch 2. And this was as of a few weeks ago, so this is, I'll give you the updates verbally. As we get into batch 2, we have finished the addition and recirculation. We've finished the coupon, and the coupon, the CST coupon, is now being analyzed at Savannah River Lab. Okay. So in batch 2, again, remember, we've got Burkite to deal with. So what are we going to do? We've experienced Burkite in tank 4. We know how to get through Burkite. We can do it. It's a slow process, but it can be done. The way we do it is smaller batches with recirculation between batches. And so instead of 150,000 gallons this time, we said 3 25,000 gallon adds. We're going to put it in, we're going to recirculate. We're going to try to get motion in the tank. We want recirculation. So we started on February 23rd. We added 25,000 gallons and we started the recirculation. We added a second 25,000 gallons on March the 6th. We decided it looked like we were getting good, steady solubility, so we decided not to add the third batch. We took density measurements. You can see how many density measurements that we took, 5 or 6 along the way. And our solubility line was a straight line, showing that we're making progress. It's slow progress, but we're making progress. We're getting through that Burkite layer. The final density check was done on April 26th. The density showed that we hit our target number, and the sodium level would be above 3.2 molar. And so we proceeded to deploy the CS2 coupons. We did that on April 30th. They hit equilibrium within the tanks that 10-day period, and on May the 10th, we pulled the CST sample out of the tank, and that sample is now with SRNL for analysis. Expectations for this batch: again, we expect the equipment to work well. We expect better data this time, so we'll have a better indication of how it's performing, but we do believe the equipment will continue to work as designed. We expect very similar decon factors, and as stated, we do believe the campaign 2, from a data perspective and performance perspective, will be better than batch 1. Okay, so moving forward, where are we? Right now we expect we'll get through batch 2. As we get through batch 2, we are going to do some hydrolancing in the tank. So we have put a work order in place to bring in a contractor with a water jet who will jet down through the Burkite around the center riser and try to put a few holes in the Burkite. We think that'll speed up some of the dissolution of the Burkite. So we'll be doing that between batch 2 and batch 3. We expect campaign 3 will be similar to campaign 2, except shorter, we hope. We have made it through about 4 inches of Burkite. We're unsure exactly what that layer of Burkite is. We optimistically think that we've gotten through about half of it, so I'm not going to make a promise there. Jim might throw something at me, but we hope to get through the Burkite layer in another batch. We will again use smaller batch sizes and incremental water additions and recirculation to again get rid of the Burkite. And then once we do get rid of the Burkite, again, hopefully by the end of the third batch, we will go back to the bigger batches and start processing larger batches at that point. We'll have to see where this goes, but we hope that we can get back to these larger campaigns. So as we get through the larger campaigns, we are going to reach a point of inefficiency with ticker. And what I mean by that, we'll be processing ticker, we'll be processing through the columns, and as we get to the bottom of the tank, the concentration of cesium in the bottom of the tank is not as great. What do you have to do? From a column perspective, either you need to increase that contact time if you're with the resin, if the concentration is lower. So that means you either slow the process down, our target is 5 gallons a minute, either slow the process down, or you need more column time. And the only way to do that is add more columns. So that we would not do that at this point. So you will reach a point of inefficiency through the columns. And at that point, we'll say, okay, we've taken it as far as we can at this point. So we'll see how that goes with future batches. Feasibility study. Feasibility study needs data. We talked about the first batch being not the best batch to actually start tracking the data on. Batch 2, we expect it to be good. Batch 3, we expect it to be good, and future batches. But we're not going to get 6 batches as planned before September 30th. So we're going to remain on schedule with the feasibility study. We will prepare the feasibility study with the data that we have based on fewer batches. All right, Jeff has already talked about Tank 9. We're going to bring the Tank 9 materials. After we finish Tank 10, we're going to bring the Tank 9 materials over from Tank 9 to Tank 10. There's a project, modifications have already started on that. And so once we finish Tank 10, we will bring over the materials from Tank 9. It'll be dissolved in Tank 9. We'll qualify it in Tank 10 and then feed it through ticker. We'll also need more columns, more CST, and we've got a project in place that we're initiating to start that. And ticker unit 2, we've already talked about. Sonny did a great job talking about it earlier. So for the rest of this year, what we plan to do in parallel with the feasibility study is we plan to do some very early conceptual planning for ticker 2. So that is where we're headed for ticker. Any questions for myself or Jeff?
Any questions, folks? Bob, let's start with you.
Robert Smith, Cab. If my math is correct, and based on the numbers that you put up, you're talking about roughly 48 or around 5,000 columns. Is that correct?
The 25,000 curies per column was a very early plan. We believe we'll be able to load them higher than that in the future.
Okay.
So I don't see 5,000 columns.
And secondly, with your phase 1, your campaign 1 and campaign 2, were you using the same column or were you using a different column each time you did that?
We've used columns 1 and 2 on campaign 1. We may be valving in column 3 for this second batch. We haven't made that decision yet.
Okay. And have you looked at the effective temperature on the water as far as solubility? And also the possibility of DI water versus local water?
We've looked, yes, on temperature. Lower temperature works better. We do know that. DI water, our DI plant, it takes so much to make up DI water, and we make it up in 10,000 gallon batches, that to make up DI water at 150 gallons would take, I don't know, 6 weeks. So we need to fill a tank up in a day or two.
Okay, I guess just from a scientific standpoint, it might be an interesting experiment to run on a lab scale basis to see what the effect of DI water, if calcium or other ion have an effect on the solubility and or ability of the ion exchange resin to collect material.
Okay, thank you. I'll take that back to my engineering staff.
Jim?
Thank you.
Yeah, Robert, your first question there, Robert, maybe I misunderstood it. Were you asking about number of columns or loading on the column?
Number of columns.
Yeah, see, you answered a loading on the column. He was asking about how many columns we're using for this effort. Is that correct?
Right.
Oh, excuse me, for this effort, 4 columns.
Well, I know, but if you were to do tank 10 total, what would be the total number of columns that you would go through, that you would have sitting out on that pad after that campaign, after the total campaign of tank 10?
Sure, so 4 columns for the campaign, the current campaign for tank 10. When we bring the tank 9 materials over to tank 10, right now we're thinking about 12 more columns.
Okay, I think I misunderstood. I thought 25 was 25 curies, but you're talking about 25,000 curies.
That's correct.
Per column. So
25,000
that's significant.
Correct. All right.
Okay, let's come all the way over to Doug.
Jeff and Penn, great presentation.
Thank you.
I have a couple of questions. Did you say the ticker was initially set up and assembled at Hanford?
It was set up and assembled by our contractor, Westinghouse Electric Company, at their location in Richland, Washington. So it was not at Hanford, but it was in the same location. No relationship other than close proximity.
Is there any reason why it could not have been assembled here in Savannah River on this site? We bought the expertise for this. So we bought the engineering, we bought the fabrication. We don't so much do specific engineered type fabrications. We will buy the engineering and we go to an off-site vendor to buy the actual engineered components. Typically what we do for most of our engineered components, pumps, we go to a pump vendor to buy pumps. VFDs, we go to a VFD vendor to buy VFDs. So any of the machines that we can go buy from experts in the field, we will do that. We will do the installation, the hookups, and the utility work generally. So generally how we do things on site. If we were to fabricate ion exchange columns, we would not be cost competitive. Do you foresee having to use more than 2 tickers in the future? Because you said you're going to go to a second ticker, correct?
We are going to a second ticker, correct?
Right.
At this
Jim?
point, no.
What do you think, Jim? Nope. Okay.
Okay, and then on slide 4, you had down that the supplement salt waste treatment and accelerate waste removal from old style tanks. Is a ticker just used on the old style tanks, or can it be used also on the newer style?
Yeah, there's no restriction on the type of tank. It's just we're trying to get it out of the old style tank. So.
Okay.
Correct.
And then how many operators are required for the ticker to be put in use?
Ticker is an unmanned operation. So under general operations, we do not have a person assigned to ticker. When we start it up, we have a person assigned, and then it's handled over rounds. We have alarms that go back to the control room. If we get an alarm, we dispatch an operator. An operator will then determine what goes on. And of course, we have fail-safe. If there's leaks or anything like that, boom, there's a fail-safe, and the system automatically shuts down. So we have a qualified operator, at least one on every shift, and but the system and the processes tend to be unmanned.
And the last question, the sodium problems that you had with the Burkite, I think, you didn't have those same problems when they tested them there in Richland?
No, the Burkite is not a ticker issue.
Okay.
So when the ion exchange and CST columns were being fabricated and the ticker equipment was being fabricated, we didn't feed any type of Burkite or anything through that. But the Burkite is a product of what is in the tank at Savannah Riverside. So no, we didn't test the ticker equipment with Burkite. We did test it with solids. but we did not test it with perkite.
And there would have been no reason for you to know to do that testing near it in Richland, excuse me?
We tested it, in Richland, we tested it with a very, very high soluble, very high sodium simulant with solids. So we tried to duplicate what was in the tanks as much as we could. Now the perkite is solid, okay? That is a solid form, so it will not, you can't put a solid through ticker, you have to dissolve it. So the process we were trying to do, we're trying to dissolve that perkite. Once we dissolve it and get it into a liquid form, we can process it through ticker. That answer your question?
Okay. So through, I guess, computer analysis or testing or anything like that, knowing what was in the tanks here, you weren't able to recognize that you would have problems like that?
We know that we've got some hard soluble salts in different tanks. The presence of this was below another salt layer, and so we didn't experience it until we hit it.
Thank you.
But we can get through it, it just takes more time.
Okay, Malcolm?
Just a quick question. You were talking about the SAR, the development of the safety analysis, and you mentioned that there were 15 admin controls
Correct.
that were needed to go into the safety to complete the safety analysis. Could you give us an example of those, and does that trouble you?
Well, and I won't know them all. I'd have to bring an engineer in here to go through them all, but each one of them has some type of chemistry content. So IDP, inhalation dose potential, one for sodium, one for plutonium, one for actinides, da-da-da-da-da-da.
And does the number of admin controls necessary to complete the SAR trouble you?
Excuse me?
Does the number of admin controls to complete the SAR, does that give you pause at all?
No. I mean, it's not difficult. It's cumbersome to work through, but it's not difficult. And this is what we do every day. This is why you hire an SRR and to go run nuclear operations at Savannah River or something like that. And we're not hiring a different type of contractor. This is what our company does every day, and this is what we're good at.
Robert?
Robert Smith, Cab. You made the comment that the perkite was underneath another layer of salt, and I believe you said that perkite primarily exists because of nitrates and nitrides. Do you understand why the difference in concentration of nitrates and nitrides and nitrates was there, or was it just a random thing in terms of the overall filling of tank 10?
Well, we had some indications that we may have a difficult layer to get through. Reason why we were trying to get water in the tank as quickly as we could to start that dissolution aspect. There had been 2 prior campaigns back in 2013 on this tank. They were able to get through 2 layers of salt, and then they stopped. So we knew that we had a difficult time coming up. We didn't know that we had perkite there, but we knew we had a difficult layer of salt to get through. So we got water in the tank a month earlier to try to start that recirculation of the tank. We built recirculation in. Some of the other salt dissolution techniques do not have recirculation built in. We built that into our design to enhance that salt dissolution. So we prepared for it, thinking that there may be a difficult layer to get through. And again, when on the first batch, we confirmed that we did have that difficult layer there.
Okay, and then you also said that the presence of calcium, I believe, confounded your results from the first campaign, and you changed water sources. Does that imply then that the calcium was coming in with the water that you're using to start with?
Sure. Look, it could only come from one of two places. It was either in the tank or it was something we added. Okay, and so we do know that the well water at the time that we added, we did do an analysis of it. It showed a very, very high calcium content. And so we suspect that we added it to the tank.
Okay.
That is why we shifted over to domestic water.
And that's primarily what prompted my suggestion about the DI water, was the fact that you probably need to deionize that in a more economical way if you can, so you can maximize the efficiency and the effect in the tanks.
Understand. I'll take it back to my engineers.
Thank you.
Okay. Any other questions?
Questions?
Gil?
James, you made mention earlier today about Hanford, and maybe this is more of a question for DDFOs and Mike. One of the things that has been tasked to the site-specific advisory boards by EM1 and White was that there be a cross-complex sharing of knowledge. Last week, James did make a point earlier, but last week Hanford was very interested in our ticker process. Are we communicating? I mean, can it be something that works for them as well? What's the things that, I mean, because I know some of the things that we do don't translate, but does this translate out there? And can we help them?
Yes, and just to let you know, we are communicating. I've reached out to my DOE counterpart out there, who is the project director for the TCCR process. We've shared lessons learned. I've hosted him and a few others at our site to go out and see the process and, or the locations. And I believe on the contractor side as well, I believe they're working together. Penn could give you a little bit more on contractor to contractor, but.
So we've shared documents, we've shared our DSA, we've shared our designs, we've shared quite a bit of information with TSCR. They are now sharing some of the analysis with us that they're doing. We had a joint meeting with the manufacturer of the CST at the Waste Management Conference. And following behind that, about 2 or 3 weeks after that, we went out to Hanford for a lessons learned session. We shared lessons learned. They shared some of their very early engineering thoughts for TSCR. So we're doing exactly that.
Great.
All right. Any other follow-ups? Gentlemen, thank you. All right, so next up on the agenda, we have public comments. Went checked a minute ago, nobody had signed up, but out of due diligence have to ask. Is there anybody in the audience who would like to make a public comment? Seeing none. So let's move on to voting. So while Heather starts to pull up the first agenda item there, the recommendation 358 and the DOE response, I want you to note that we're going to do things a little bit differently today than we have in the past. Last time we voted, we had the clickers that we were doing. We're not going to do those today. You ever done 2 meetings back to back and left something in the office? Happened to us, left the clickers. But we have a paper ballot for you right in front of you, up under your nameplate if you haven't looked at it. No motions have been made, so please don't start voting yet. I'm going to ask that you wait, okay? We're going to discuss every item one by one, make a motion, and then vote in total. So and once everybody has a chance to vote, I'm going to come around and pick them up. We're going to collect them and count them. While we're doing accounting, we'll do a little Q&A session, see if we have any lingering questions from the day, other things you've thought of, any things that we need to talk about in order to have a successful meeting for today. So in the meantime, please just wait a few moments before you start voting. Let's get those motions completely done. One thing is at the very top where it does have your name. That is only just, I do ask that you write a name there. That isn't so that we can judge you by how you voted later on. I honestly don't care one way or another how you vote. I just want to make sure that only people in the room are the ones voting, and we don't have duplicate ballots anywhere. We try to make sure that only put one per nameplate, but we're going to make sure that we don't have any duplicates or anything, any rogue votes anywhere. Okay, so Heather, can you pull up the DOE response to 358? So this was the recommendation. The committee at the last meeting talked about this one about, this is the restart the SRS INL exchange. This was a nuclear materials committee recommendation, I believe, Charles. And if I recall, the board members were very happy about it. Do you have anything that you want to say before we ask somebody to make a motion? Gil, do you want to ask for a motion to be made to close?
Is there a motion to close recommendation 358? Narinder makes the motion. Do we have a second?
Second.
I don't know who did the second. You got it? Bob? Okay. Any discussion about closing 358? Sensing no discussion, please vote on number 1, yay if you choose to close it, nay if you choose not to close it, or abstain if you choose to abstain. Okay. I guess we'll tabulate these after.
Yeah, we're going to tabulate them all together. So
We'll make an announcement at this board meeting.
absolutely we will. In fact,
Okay.
while Heather's counting them up, we'll just do a Q&A amongst ourselves, see if there's anything that we need to talk about that we haven't talked
Fair
about
enough.
yet.
Okay.
So the IPL list, let's do that one next.
I'm going to defer to Charles. Are you comfortable reading this out loud into the record for us as written? Okay.
I'll do it for you.
Okay, James will do it. Thank
Heather,
you.
you put it back up for me.
Thank you.
The Savannah River Site Citizens Advisory Board appreciates the opportunity to provide input to the site's prioritized activities for FY 2021. As in the past, the high-level liquid waste management program remains our highest priority. We ask that the budget request for FY 2021 reflect this priority and be at a level that guarantees compliance with all state and federal agreements. The SRS CAB also places a high priority on the complete funding of payment in lieu of taxes to Aiken County, Barnwell County, and Allendale County. In regard to all environmental management mission activities, recommended priorities are as follows. 1, liquid waste program. 2, common and program infrastructure across the entire SRS complex to be addressed down to PBS levels. 3, nuclear materials. Thank you for the opportunity to submit our recommended priorities for the budget request for Savannah River Site for 2021.
Do I have a motion to accept the IPL letter as written?
Motion to approve.
I have a motion. I mean, you have who it is.
I missed who it was. AK, you got it.
Motion from AK. Do I have a second? I have a second from Betty. Okay. Any conversation on the IPL letter? Sensing no discussion. Vote yay if you accept this letter as written. Vote nay if you do not accept this letter as written, or abstain if you choose to abstain. Thank you. We will move on to item number 3. Motion to approve chair recommendation number 1, cleanup milestones. We discussed this at some length yesterday. The recommendation was for EM to create a complex-wide, consistently applied data dictionary for milestone terminology, among other things. Do I have a motion to accept this as submitted by the All Chairs Committee? Bob, I have a motion. Do I have a second? Doug, I have a second. Any discussion on this particular recommendation? Sensing no discussion, vote yay if you accept this. Vote nay if you do not. Abstain if you choose to abstain on number 3. Moving to number 4. Motion to approve the chair's recommendation number 2 on science and technology program. We had some discussion about this as well yesterday. This one talks about supporting the development of a programmatically integrated, robust science and technology effort that is fully funded into an order as follows. Quite a few other things listed in here as well. Do I have a motion to accept this as submitted? We do not have a motion. Bob, okay, I have Bob with the motion. Do I have a second?
I second it.
I got Narendra with a second. All those in favor of accepting this motion as submitted, circle or mark off yay. All those that are not in favor of this, please circle or mark off nay. If you choose to abstain, choose to abstain. I won't know, but I'll still make fun of you if you abstain. Number 4, okay, we're moved on. Now moving on to number 5, motion to approve draft recommendation preferred H Canyon future operation options. This one was brought to us by recommendation Dave Eisel. Do I have a recommendation to put this forward?
So moved.
Second.
We got those with, who was the so moved? Dave?
Dave, so moved.
Okay, Charles second. Dave Vavakis.
Yes.
Mr. Eisel, do you have anything you'd like to say about this?
I didn't write it.
H Canyon?
H. Canyon, recommendation manager Dave.
No.
Okay. Do we have any other conversation around the table about preferred H Canyon future operations options? Sensing no more discussion, please circle yay if you are for this recommendation, circle nay if you are not, abstain if you would like to. Moving on to number 6, motion to approve draft recommendation accelerated if I could speak today, deactivation and decommissioning of 235F as submitted by Charles Hilton and Narendra Malik. Do I have a motion to put this forward?
So moved.
Okay.
I have a motion from AK. Do I have a second?
Here.
I have a second over, I can't see.
Jim.
Okay, Gil. All right. Narendra or Charles, do we have any words on this recommendation?
Discussed at length yesterday. No further comments.
Narendra? Okay. Does anyone else want to have any discussion on this recommendation? Sensing no discussion, I put it forward to vote. Vote yay if you are for this recommendation moving forward, nay if you are not, and abstain if you are going to abstain. Again, I will make fun of you if you abstain and I find out.
Okay. So I'm going to come around and collect your ballots from you. Just for the sake of transparency, I want to state out loud, the blank one, I'm sitting right here. So
there, that was the exact number
what do you mean?
printed out. I mean, you have
Yeah,
no extras.
I had the number that I needed.
All right. It feels old school.
Thanks. Thank you. Here. No problem.
Yeah. When they unloaded the van from
Thanks.
Augusta last week, they unloaded it. They left it with me when they got down. So, yeah.
Thank you.
I would like to have it, I do. Hopefully, all CAB members, you received your Savannah Riverside Citizens Advisory Board reimbursement. If you haven't signed that and turned it into Heather, please do so before you leave the meeting, or you will not be reimbursed for your travel. And James is back, so James is going to take it away.
So those of you who did park here at the hotel, a few of you have asked, that is covered by your reimbursement. Actually, we'll be taking care of it on the hotel side, so you shouldn't even need it in your reimbursement check. If you drove locally, though, and you have parking receipts, I'd love to have them. That way we can make sure that we get your reimbursement for that. Other issues that we wanted to talk about today, I've only gotten 2 compliments on my tie that my wife picked out. And it was, yeah, I thought it was going to go over a lot more than it did, but you know, whatever, that's fine. We talked about a number of things today. We went through deactivation and decommissioning, some common infrastructure. We talked about the budget update and liquid waste system plan and ticker. Are there any lingering questions, any issues that we needed to discuss? Anybody have anything that felt like they didn't get to answer it? Bob?
Well, not for the Robert Smith cap, not from this meeting, but in discussion, some of the things that came out in this, Angela Holmes and I were talking earlier, and she and I both felt that sometime in one of the next full board meetings might be a good time for them to present their latest and greatest activities on the reclamation activities they're doing in terms of technology and science that's being used in that area. The second thing I'd like to bring up is I would like to possibly hear an update from the National Lab on efforts and lessons learned from their involvement with Fukushima.
Okay, that's interesting. Lessons learned on their efforts at Fukushima, and then the environmental remediation technologies. Okay, those are something that we can take down and take back to the office and see what we can do about it. AK?
Yeah, AK Hassan Kayab. I just wanted to be clear on the list that Mr. Richards provided in terms of from the EPA and the Superfund and the tripart agreement between DOE, EPA, and South Carolina DHEC. I'm not clear on whether that list is exclusive to environmental management, because it references things on the site, and we also have a dual participant out there with NNSA. So I'm just trying to find out those exclusively issues that we deal with, or is that a kind of shared responsibility issue?
I would ask John, but it looks like he's had to step out. But that's something that we can get an answer for you, and we can find out how that list was calculated or pulled together. Doug?
Doug Howard Cap. Another great meeting, and I do have a question though, James. I know we do a survey throughout the year on the presentations, and I think we used to do them after each meeting.
Okay.
And I think it would be a great idea if we continued to do that after each meeting, because I think those presentations would be fresh on our minds, and any changes or ideas that we might have. And as I said about Sonny Blanco's presentation, to me personally, it has gotten better for me to understand. And I think if we are able to put down anything we like or dislike, during this present meeting, it would be helpful to everybody, I think.
You filled out the survey at the chairs meeting, and that's the exact same survey that every single one. We could duplicate something like that. About what they put out, that was in your packet. We just add it to your packets as a standard printout. If that's something that you were really interested in collecting data on, we could do that. Okay.
Yeah, I think it would be helpful, I believe.
Who received those from the other meeting?
Those go to headquarters. Any other questions, comments, thoughts, ideas? I need you to fill like 3 more minutes.
We still need 3 more minutes.
Carl?
Yeah, just one general comment, probably mainly for the future. But today was a good example. And yesterday we learned a lot and talked a lot about process, about deactivation and closure. But really, the big question, I think, in a lot of people's minds, ours and the public, is this quote-unquote temporary on-site storage, the half-life of what we're storing there or some other measure, and then maintenance and then permanent storage. That's probably a big question that maybe it's above our pay grade to answer a lot of that, but those are the questions that linger in my mind for the future. In a future meeting, maybe some update or estimation of those things. We usually reference it, but it's pretty fuzzy.
I think what might be interesting is that this is, at this point we have a lot of members who are in their very first term, whether it be their first year or their second year. Everybody who's still in their first term, can I give you a little bit of homework to do? Can you do something for me? I want you to send me an email of just all the questions that you've had over the past, whether it be 2 meetings or 6, 7, 8 for some of you at this point, let me know what's still unclear. And we can do this for everybody too. If you're having questions about something that seems like it's repeatedly coming up and you just don't, you feel like maybe you don't fully understand it, or there's some unresolved issues, let's do this within the next 2 weeks. Send me an email. Let me compile those together. We'll talk with the department about what we can do to further that along. Maybe some things are topics where we're just going to get to it down the road and we're going to have to live with you being fuzzy. But maybe there's some areas that we really can improve on what the base level of knowledge is around the table.
James, are we still sending people to the CAB University?
Yes, we are. Everybody's doing that. And so we've got some great feedback off the videos. There were some questions about the quiz in this last round. I think that we need to go back and take a look at those questions and answers that we had. But I think overall, those have been very helpful, honestly. Over the years since that's been implemented, just anecdotally, I can say that the starting point for members has come from here to up here. So I've got results if you want them. You ready?
Yeah, you go ahead and you can
All right. So 358 was 20 yeas, 1 nay, and 1 abstain.
I'm making fun of you.
The IPL was 20 yeas, 1 nay, and 1 abstain.
Probably the same person.
The chair's recommendation, number 1, was 20 yeas, 0 nays, and 2 abstains. Chair's recommendation number 2 was a little more controversial, but still passed with 16 yeas, 5 nays, and 1 abstain. H. Canyon recommendation, that passed unanimously.
Great job.
235F was 21 yeas and 1 abstain.
Wow, those are wonderful. That's great to see. Nuclear materials, job very well done on both of those recommendations. Timely, and thank you, CAB, for having good discussion around those recommendations and coming out with such a strong voice. That helps us. When we give them, I consider the abstention is still a unanimous vote. So unanimous on both of those. That's absolutely wonderful. Now, as far as the chair's recommendations, those will go back to headquarters, and we have approved both of them. So those are now out of our hands, and they will be handled with in Washington. We will get EM1 and White's response. Typically, it's about 2.5 to 3 months to get that back from that office. So we probably won't hear about that at the next full board, but it'll be 2 full boards from now. Do we have the committee schedule available to be pulled up?
Let's see, it's nuclear materials and waste management on June 11th, and then strategic legacy management. No, wait, we changed those up, didn't we?
Yeah.
Can you pull up the committee schedule, Hannah? If you just pull up on the CAB website, it'll.
What I just basically before we break, and I drag this out another 2 minutes, but committee meetings, were mentioned yesterday. Please make every effort to attend your committee meetings. And I know there's been some people who've actually gone to committees that they're not members of. If you are a member of the CAB, you are invited. Well, if you're anyone, you're invited to all our meetings. But especially CAB members, if you come to a committee meeting that you're technically not on, please still sit around the table, have conversation, completely open to the public. There's going to be a lot of discussion at these next committee meetings. Waste Management is going to have a pretty big committee meeting going on. So you're highlighting them. I can't really see.
Strategic and legacy management and nuclear materials are on June 11th. And then on June 25th, waste management and facilities disposition and site remediation.
Right. So please make every attempt to be there. Our next full board meeting will be in
July in North Augusta.
July in North Augusta. So that's really one of my favorite places to go. This is a great setup, so is North Augusta. So, and who knows, maybe James and his staff will get you into the hotel right near it. That'd be nice.
Fingers crossed.
Fingers crossed. Great day, great 2 days of meetings. Thank you for coming down to Savannah. Thank you for taking time out of your schedule. And I look forward to seeing you all at committee meetings in a few weeks. Without anything else, meeting adjourned.